Hello and welcome to video number 5 of the Detector Education program. In this video we are going to learn about detectors. Specifically single variable detectors. What is a detector? A detector is a specific algorithm trained to detect specific anomalies. Mindset detector has 15 types of detectors. 5 of them are single variable detectors. Each detector has several common fields which control its activity. For example, each detector has a delay time. The delay time is the amount of time the detector waits before sending an alert. We recommend that you read the detector's courseware after viewing this video in order to become familiar with each detector's specific parameters. There are 5 types of single variable detectors. We will explain how each one works. 1. VAR outside of user limits. This detector detects when a single variable is outside of its user limits. User limits is what the user sets according to regulatory limits. For example, is some states water, with a turbidity level of above 1.0 NTU, is not recommended for drinking. 2. VAR outside of statistical limits. This detector detects when a single variable is outside of its statistical limits. Statistical limits are learned based on the periodic time format. The significance of the statistical limits may be set in the Learn screen. Please note that statistical limits should be narrower than user limits. The gap between user limits and statistical limits is what creates the additional time for reaction before an event becomes severe. 3. VAR is fixed. The VAR fixed detector detects when a variable shows a fixed value for too long. This may happen when the sensor is not functioning or during a communication failure between the field device and the server. 4. VAR long trend. VAR long trend sends an alert when the sensor's measured value shows a trend that can be noticed only over a long period of time. A typical trend is targeted to detect a crawling in the sensor value over days or weeks. 5. VAR rock. The VAR rate of change detector, referred to as the rock, detects sharp changes in the sensor's value. For example, a drop in chlorine levels of more than 0.25 ppm within a 15-minute time window. Such a change is an indication of some organic contamination which consumes the free chlorine. Detectors are model specific. This means that in order to define a detector one must activate the model's main panel. You may view the detector's setup while the model is running. However, if you intend to change the detector's setup you must switch the model status from run to pause. This is done by using the on/off buttons located at the top of the panel. To do this, enter the detector's setup panel by clicking the circled button. The detector panel enables the user to manage the detector's setup. The table in the center of the panel shows the currently defined detector. The button on the left side enables the user to perform a list of functions which will be explained in a moment. The following functions can be activated using the buttons on the left side of the panel. Create new detector. Update existing detector. Delete existing detector, and refresh the shown list of detectors. Export the detector definition to an Excel file or send it by mail. Activate or deactivate all detectors. A deactivated detector will not be scanned. This may be useful, for example, when a sensor is under maintenance to prevent receiving irrelevant alarms. The last 3 buttons enable the user to copy a detector's definition to other models or to copy a setup from one detector to other detectors in the current model. And finally, we have the detector's auto creation button. When you create a new model, you may use this button to quickly create a default setup for the detector. The filters in the upper right-hand side of the window are for displaying detectors by their key parameters. The filter at the bottom of the window is for displaying parameters by detector type. This window will be shown after clicking on the Create New Detector screen. This screen is used to define a new detector. Start by selecting the detector type. Then, in the case of a single variable detector, you should define the selected variable. This is done by selecting the drop-down field, which contains all of the model's defined variables. The delay before trigger field is used to set the number of minutes the detector will wait before firing an event based on this detector. Note that this delay time is the time it takes the event to go from a pending state to a trigger state. The delay before operational change field is used to define the amount of time after an operational change the detector will wait before firing an event. For a definition of operational change, please refer to the detector's user manual or to the relevant tutorial. Delay after last event closed is used to avoid the creation of a large number of small events. If a new event starts, and the time that passed since the last event was closed is smaller than the amount defined in this field, the new event will be added to the last event to create one long continuous event. Notification policy is the frequency used to notify the user about events. Options include every event, every hour, every day, or none. Base severity defines 4 levels of severity: none, low, medium, and high. It is the user's responsibility to define each detector's severity. Note that the severity of an event is defined according to the highest severity of the detector that was fired during the event. Block rule on and block rule off enable the user to define options that control when events are fired using rules. For details about rules, please see the user manual or the relevant tutorial. The last slide shows the detector's related information while the detector is running. This includes 3 types of information. The first is relevant sensor limits, such as statistical limits, average standard deviation, and median. These are displayed in the upper right-hand box. The second is history of changes made to the detector. These are displayed in the lower right-hand box. The third is detector performance. This includes the counting of true positive, false negative, not classified, and classified as other events, in which the detector was involved. This table indicates the detector's performance over time. In this tutorial we went over single variable detectors. If you have any comments, suggestions or questions, please do not hesitate to post them or email them to the address that appears in our education program reference mail. This ends movie number 5. We hope to see you at movie number 6.